Hey there, algebra. We are starting lesson 22. We're getting, we just got into inequalities. This is our second day with two variables, which remember, one variable is just like 1x. Two variables, we can graph a line and shade around it is two variables. So let's just jump in. To begin, landscaping options. A homeowner is making plans to landscape her yard. She plans to hire professionals to install grass sod in some parts of the yard and flower beds in other parts. Grass sod installation costs $2 per square foot. There we go. And flower bed installation costs $12 per square foot. So there's our two variables. We have sod and flower beds. Her budget for the project is $3,000. So write an equation that represents the square feet of grass sod X and the square feet of flower beds Y that she could afford if she used her entire budget. All right, so her entire budget is $3,000. She needs to use less than or equal to $3,000 because she can't spend more than that. And she's going to do $2 for every square foot she puts in of sod and $12 for every square foot she puts in a flower bed. And that's, I make that seem really easy maybe, but it takes practice and it's not always easy. All right, so on the coordinate plane, sketch a graph that represents your equation. Be prepared to explain your reasoning. When I sketch graphs like this, I just find the x-intercept and the y-intercept. So the x-intercept is where the x-intercept is where y is 0. So this right here is the y-intercept. And then the x-intercept is where, yes, y is 0. Oh my goodness, it's still early. So I'm going to substitute 0 in for x. Let's see if I can change colors. So 0 in for x. I can make it an equality. So if I put 0 in for x and then I divide both sides by 12, I get the y-intercept. 250. So y equals 250. I go to the y-axis, I put a dot. So that would be 250. Now the x-intercept, I put 0 in for y. So 0 in for y, divide both sides by 2, x equals 1,500, which is right there. And then I'm not going to be able to draw a line, but I'm going to do my best. Not bad. I would ask you guys to use straight edges. So this is a graph that represents your equation. Be prepared to explain your reasoning. I'm not sure if I should shade here or here. So I'm going to test a point. I'm going to say, I wonder if 0, 0 makes this inequality true. So if I put 0 in for x plus 0 in for y, is it less than or equal to 3,000? Well, those all wipe out. 0 is less than 3,000. So I want to shade where that 0 is. So that right there is the solution. Okay, this is the graph that represents your equation. Okay, it's not an ordered pair, it's not just a line, it's a line that's either solid or dashed that has shading in it. All right, so rethinking landscaping. The homeowner is worried about the work needed to maintain a grass lawn and flower beds, so she's now looking at some low maintenance materials. She is considering artificial turf, which costs $15 per square foot to install, and gravel, which costs $3 per square foot to install. She may use a combination of the two materials in different parts of the yard. Her budget is still $3,000. Here is a graph representing some constraints of the situation. Okay, so this graph is actually different because it doesn't cross at 1,500 like the last one did, right? So let me erase that because I don't want to confuse you. All right, so the graph shows a line going through 500, 100, right there. In this situation, what does the point 500, 100 mean? Well, 500, that would be your square feet of gravel. So that would be 500 square feet of gravel and 100 square feet of, so the x-axis, or the x value was gravel, the y value is turf. So that's what that ordered pair represents. Write an equation that the line represents. So same type of equation, and we're doing the line. So that would be, let's see, turf was the y value, gravel was the x value. So 3x plus 15y equals 3,000. Okay, that's the line, not the inequality. Inequality is shading. Lines are lines. What do the solutions to the equation mean? The solutions would be the amount of gravel and turf that equal her budget. You can say the amount of gravel and turf, what's her name? The homeowner. The homeowner can purchase and still be within budget. Okay? The point 600, 200 is located right and above the line. So that's this one, 600, 200. Does that combination of turf and gravel meet the homeowner's constraints? Explain or show your reasoning. So it was 600, 200. So 3 times 600 plus 15 times 200. So that's the amount of square feet that they, and that has to be within the budget. So I'm going to do the inequality because I want it to be $3,000 or less. So 3 times 600 plus 15 times 200. Okay, that is 4,800, which is not less than or equal to 3,000. So does it meet the homeowner's constraints? No, it doesn't meet. Okay, it's out of budget. It's too much money. Choose another point in the same region to the right and above the line. Check if the combination meets the homeowner's constraints. Let's do this. So gravel is 100, turf is 225. So gravel is 100 and turf is 225. Okay, those are smaller numbers. Maybe, a question mark there, maybe they will be within budget. 15 times 225. That's 3,675. And that is also false. Okay, so that does not meet the homeowner's constraints. Okay, the point 200, 100 is located to the left and below the line. Let's change colors. Let's go with red. Right here, 200, 100 is left and below the line. Does that combination, so it was 3 times 200 plus 15 times 100. That needs to be less than or equal to 3,000 to meet the constraints. Yep, $2,100. That is true. So yes, it meets the homeowner's constraints. Choose another point in the same region. Check if the combination meets the homeowner's constraints. Let's jump doing way over here. That would be 725. 700 and 25. So 3 times 700 plus 15 times 25. Is that less than or equal to 3,000? Sorry, I got distracted. There we go. 2,475 is less than or equal to 3,000. So true. Yes. It does work. Write an inequality that represents the constraints in this situation. Explain what the solutions mean and show the solution region in the graph. I already did that. So our inequality is 3x plus 15y has to be within budget, so less than or equal to 3,000. And the solution, if you go back up to the graph, are all the ordered pairs to the left and below the line. So every single ordered pair that is within this shaded region is a solution, including all of the dots that make up the line. That's why we made it a solid line, because those are also solutions to the equation. All right, the Saturday market. A vendor at the Saturday market makes $9 profit on each necklace and $5 profit on each bracelet. Find a combination of necklaces and bracelets that she could sell and make exactly $100 profit. So I want $9 for a necklace plus $5 for a bracelet. It has to be exactly $100. So let's just look. Let's see, if I sell 2 bracelets, just guessing, how many necklaces could I sell to make exactly a $100 profit? I'm not sure if this is going to work. Yeah, so 5 times 2 is 10. Subtract 10 from both sides. Oh, sorry. So that's 90 in the wrong spot. So n equals 10. So I could sell 2 bracelets, and 10 necklaces to make exactly $100. Okay, I'm going to go ahead and erase all of this work, but you can write it down. Just push pause. Because we don't have enough space. There's never enough space. All right, how about more than $100 profit? So now we want, so this right here would be 9n plus 5b equals 100. Now I want it to be more than $100 profit. Greater than or equal to, well, it just says more than, so that's just greater than $100 profit. So let's do, I don't know, 10 bracelets. If I had 10 bracelets, that would be 50. Okay, subtract 50 from both sides. 9n is greater than 50. Divide by 9. I know I'm going to get a decimal. So n, and actually we've been teaching you to do equalities and then figure it out at the end. So n equals 5.6. It can't be. All right, I got distracted. Now I have a mask on. So let's see. I think we were on number 2. Write an equation whose solution is the combination of necklaces and bracelets. Nope, we did that one. Oh, wait. Write an equation exactly $100 profit. As usual, I got ahead of myself. And that is right there. Okay, so that would be an exact $100 profit. And then more than $100 profit. So that would be the, oh, it does right over it. That one right there. As you can tell, my mind thinks very algebraically. So when I'm asked to come up with combinations to sell things, I write an equation where you guys might just be able to figure it out a little bit. And then when we graph the solutions to the inequality, remember inequalities are graphed with shading. Let me grab that equation. 9n plus 5b is greater than 100. We are going to make that n an x and the b a y. We're going to find 0, y, and x 0. So if we plug in 0 for y, that gets rid of the 5y. We have 9x equals 100. I'm not in my room now, so I don't have my calculator. Oh, my head's in the way. So x equals 11.1. So we're going to put our dots approximately 8, 10, 12, 11.1. And then our y. Oops. So to find that other value, we're going to make x 0 and have 5y equals 100. So y equals 20, which is right there. Now here, our inequality is just greater than. So now any dot actually on the line is not a solution. So that's why we need our line to be dashed. And then anything outside is a solution because we want our solutions to be greater than 100. And let's check. Is 3, 18.6 a solution? So 3, 2, 3 is right here. I believe it is because it's in the shaded area. Let's double check with algebra though. 9 times 3 plus 5 times 18.6. $93. All right, 93 plus 27 is 120. 120 is greater than 100. So yes, it is in fact a solution. Okay? So here we have a popular band is trying to raise at least $20,000 for charity by holding multiple concerts at a park. It plans to sell tickets at $25 each. For each 2-hour concert, the band would need to pay the park $1,250 in fees for security, cleaning, and traffic services. The band needs to find the combinations of number of tickets sold T and number of concerts held C that would allow it to reach its fundraising goal. Write an inequality to represent the constraints of the situation. So they're trying to raise at least $20,000, so I can start there. So it can be, now what are we doing? Tickets at $25 each, and it has to pay the park $1,250 per 2 hours. Oh, there we go, for each concert. Okay, so there is our inequality. Now, number of tickets sold is X, and the number of concerts held is Y. So there's our inequality. I'm going to go ahead and I'm going to go ahead and graph 0, comma Y and X, comma 0. So if we put in 0 for X, we get negative 1250Y is equal to 20,000. So Y, hold on. This video has been very difficult to record. I had to move again. So usually when I'm graphing, I find the x-intercept and the y-intercept and graph it. But here the x-intercept is a negative 16, which if we extend this down is, way down here. So not the easiest way to graph. If we find the x-intercept, let's do that. We're going to put 0 in for y. So 25x, 0 in for y wipes out that term, equals 20,000. And let's get the calculator. And it was 800. I already divided that. 800. That's going to be about, let's see, 5, 6, 7, 8, 9, 10. So 800. All right, so my line would be up like this. Well, not quite like that. But that's not an accurate way to draw a graph. All right, so I just need one more point out here to figure out where to draw it. So I'm going to figure out what is the y value when x equals, let's do 2,000. So 25 times 2,000 minus 1250y equals 20,000. Okay, I should have grabbed my calculator. 2,000 times 25, 50,000. Okay, subtract 50,000 from both sides. Negative 30,000, so negative 1250y equals negative 30,000, and divide by 1250. We get 24. So y equals 24, oh thank goodness. So that would be right here. So now at least I can draw a line. All right, so graph the inequality. Now, do we want to shade this side or this side? I usually test 0, 0 when I'm trying to figure out which way to shade. So if I test 0, 0, I'm going to come up here. Well, 25 times 0 minus 1250 times 0, is that greater than or equal to 20,000? 0 greater than or equal to 20,000? No, that is false. So don't shade that side, shade the other side. So every single ordered pair underneath these blue little dash marks are solutions to this system of equations. So name two possible solutions. I can say right there, 1,500 tickets and 6 concerts, or 2,000 tickets and 6 concerts. Those are both possible. All right, which combinations of tickets and concerts would mean more money for the charity? That means you want to be more than $20,000. So 1,300 tickets. 1, 2, 3, 10 concerts. That's here. I don't like that one. 5 concerts. 4, 6. So you're actually going to get more money with the 1,300 tickets and 5 concerts because you're closer to your solution. 1,600 tickets and 16 concerts. 1,600 and 1,616 or 1,209. Okay, I think it's a 1,200. Let's see. My line is not drawn well. So if the line were drawn correctly with a straight edge, we would see that that one's actually a better option. And then 2,000 tickets and 4 concerts. 2, 4. Or 2,500 tickets and 10 concerts. 2, 4, 6, 8, 10. Okay, this one's actually more money. All right, and your summary, you have that in your binder. Good job today.